Good afternoon, Cappuccino. It is definitely Friday afternoon. Sorry I couldn't get out these notes earlier, but here they are now. So we're going to add a little bit more notes. These are the last notes of the year to our notebook, and it's about finance. But before we get to writing down the notes, let's go ahead and recap the last warm-up of the year. So the last warm-up was on 5/20. Here it is. Tejas takes out a loan of $35,000 for a car. The loan is for 10 years. Don't worry about that 120 for a second. It was for 10 years at 1% interest per month. Find out how much he has to repay each month. Okay, so you could have done this with the formula from one of the packets. So you could have used the formula, which is the amount that he has to pay is equal to the present value times the interest rate times 1 plus the interest rate to the nth power over 1 plus the interest rate to the nth power minus 1. You could have used that formula, and present value is the amount of money in the loan, $35,000. R here, since they don't do R over 100, that means you need to change the interest rate to a percent. To a decimal. It is a percent, change it to a decimal. So that would be 0.01. This R would also be 0.01. N, that would be the number of compounding months that you have to pay. And so in this case, 10 years, how many months are there in 10 years? Because you're paying every month. 12 times 10 is 120. So that's why I put the 120. 120 would be the N. So if you were to actually do this problem, and I don't know why I'm using black, I use black because I don't know where my pencil is, frankly, that's why. Okay, so this would be present value, would be $35,000, and that would be the interest rate. Oops, sorry, I put an extra set of parentheses. The interest rate would be 0.01, that's my first R, times 1 plus 0.01, and then the N would be 120, because that's how many compounding periods there are, because there's one every month, and I'm doing that for 10 years, so 120. Notice the interest rate was given to you in months. So since there's 120 months, the interest rate also needs to be per month. If this had been per year, I would have had to have divided it by 12 before I put it in here. All right, and then on the bottom, I would have 1 plus the interest rate, 0.01, to the nth, which is 120, minus 1. There we go. So if you put that into your calculator, you would get $502.15. Okay, so that's how much he would have to repay each month on this loan of $35,000. Okay, we can also do this on our calculator. So let me get to my calculator. So, sorry, let's do that again. So to do this on the calculator, we would hit Apps, Finance, TVM Solver, and now we're going to put in our numbers. N is our number of compounding periods, so that's 120. Our interest rate, oh, I already have it in here. Our interest rate is 1%. Notice they went it in as a percent. The starting value, the present value, sorry, I couldn't think what P stands for, is 35,000. We don't know this one, so I could just put 0 for right now because I don't know it. Future value, 0. I don't want to owe any money down the road. I want to pay off my debt. And then we're just going to always leave PY and CY as 1. That's payments per year and compounding per year. We're not going to worry about that because we're always going to write our interest as the interest rate per compounding period, and then we're going to have our number of periods up here. So we don't have to worry about adjusting these two here at the end. Now, the one that I want to solve for is the payment. How much am I paying each year? So for PMT, I put my cursor there, and then I hit alpha, enter. And that gets me the same answer that I just did by using this big old jumbo formula. There it is. Okay, so there it is on the calculator. So now, that was the warm-up. Back to our notes. The last notes. So what I have here is I have the formulas from the worksheets we've been doing. So I just want to go over what different things stand for. Write these down for future use. FV, future value. Present value. R is interest rate as a percent, because they have this divide by 100. So if it was, say, 5%, you would write 5 over 100. And then, of course, if you divide that, you would get 0.05. Okay, so the over 100 is changing the percent to a decimal. So you don't have to do that yourself. And then N is the number of compounding periods. So the one thing that's really important is that your interest rate needs to be written in the same time units as your compounding periods. So if they give you an interest rate in years, interest per year, but you're compounding monthly, then you need to take that interest rate and divide it by 12. Okay? You need to make sure that your interest rate matches your compounding periods. All right, annuity. This is like a retirement account. So when you have a job, it's a really great idea to have a certain amount of your paycheck automatically go into a savings account. So the amount invested each period is like how much money is taken out of your paycheck and put into a retirement account. So for example, maybe you have $1,000 taken out every month and put into a retirement account. And then that retirement account has an interest rate. And notice here, you're going to write it as a decimal. It doesn't have that little divide by 100. So here you have to write your interest rate as a decimal when you put it in here. And you want it per period, however you're compounding. So if you're compounding monthly or if you're compounding annually, you need to make sure you adjust your interest rate accordingly. And then N is the number of compounding periods. So for example, if you are saving for retirement, you just save for 2 years, and your interest rate is 5% per year, then the R would be 0.05 and 0.05 here, and the N would be 2, okay, because you're just compounding each year, once a year. But if you're compounding monthly, you would have to take that interest rate, that 0.05, and divide it by 12. And this one divided by 12. And your N, that would be how many months are there in those 2 years that you're saving for. So that would be 24. Okay, we're going to go over that again when we go over an example. Also, this, we never actually have to use this formula because we're going to learn how to do this whole thing in our calculator. Okay, so this formula is not in the formula packet. That's why we need to be able to use the calculator to do these things, unless you feel like memorizing these formulas. Amortization, that is figuring out the payments on a loan, a mortgage, or after you've retired and you want to take the money back out of your annuity. How do you get the money back out? So this is how you calculate that. The amount of money, so maybe that's a payment on a loan, or maybe it's a mortgage payment, or maybe it's the amount of money that's coming to you from your retirement account. Okay, so now you've retired and now you want to get your money back out of it. How do you figure out how much money you're going to get out? You take the present value, okay, so for example, maybe you have $100,000 in your retirement account, and then you take your interest rate, okay, and again, here you're going to write it as a decimal because it doesn't have that divide by 100. Interest rate, write it as a decimal. Number of compounding periods, and make sure that your interest rate matches the units that you're using for your compounding. Okay, so if you're compounding monthly, make sure your interest rate is interest rate per month. All right, calculator instructions. So on the calculator, which I just did when I went over the warm-up, you go, let me quit first, get out of there. You go to Apps, and then the first option, option 1, that's my glare there, that's better, and then option 1 again, TVM Solver. Okay, so option 1, option 1. Then it gives you these variables that you need to fill in. So N is the number of compounding periods. I, percent. Notice here you're going to put it in as a percent. You're not going to write it as a decimal. So if it says 5%, you're going to put 5. Okay, you're not going to put 0.05. You're just going to put 5. They want it as a percent. PV, that's present value or your starting value. PMT is a payment. Okay, so this is if you're doing an amortization or if you're doing an annuity, you're saving money each month, you're putting in more money each month, and you would put it there. By the way, if you just have a regular savings account where you've put in a present value and then you don't put in any more money after that, you've put in a certain amount of money and it just sits there, then your payment would be 0. Okay, so if you want to use this, if you wanted to use the calculator for compound interest on a savings account that you're not adding additional money to on a regular basis, then your payment would be zero. This would be a zero for just putting in a lump sum of money and then just letting it sit there. Okay, future value, how much it's going to be worth down the road. And it's possible, for all the problems I'm giving you, it's possible to have payments per year and compounding per year, both of these set to 1. In fact, I'm not even sure what these stand for. So we're going to have these set to 1, but I think that's what they stand for. Then after you have everything put in, whichever one you don't know, you're going to highlight it. Okay, so if you don't know what the payment is, start out by putting 0, and because it won't let you leave it blank. You have to put something. So if you don't know what the payment's going to be, put a 0, but then move your cursor on to payment, and then in order to get the answer, you're going to hit alpha and then enter. Okay, so let's do an example. Pedro puts 2,500 Mexican pesos into an annuity. So you might recognize this from the last homework assignment. Okay, he puts 2,500 into an annuity that pays 2.8% interest per annum. That means per year. And he does this every month for 5 years. So he's putting in this much money every month for 5 years. Calculate how much he has saved at the end of 5 years. All right, so we want to set up our letters. So our N, number of compounding periods. Well, he's going to be putting in the money every month. So there's 12 months in a year. So we're going to have 12 months times the number of years, and that's 5 years, right? So number of compounding periods times 5, because we're putting in this money every month. We're not just doing it every year. Wow, that's really good savings on Pedro's part. Okay, interest. Now, since we're compounding every month, I want the interest to be per month, but this is per annum. So I'm going to have to do 2.8, and to get it per month, I have to divide it by 12, because there's 12 months in the year. Okay, so that is kind of the trick here. Notice it was per year, that was per year, but I want it in per month. Okay, so change to match compounding periods. Okay, so if you're putting in money every month, you got to make sure the interest rate is written by month. So 2.8 divided by 12. Okay, so then present value would be 0, because we're going to start with nothing. He's going to start saving money. So his payment, he's putting in 2,500 each month. And then the future value is, I want to figure out where he ends up. So what is going to be his future value? I don't know. So for right now, you would put anything. It doesn't matter. Okay. So for the future value, it doesn't matter what you put in. So you can start out by putting in, say, 0. Put this in a different color. Okay. 0 doesn't matter. Anything doesn't matter. Doesn't matter when you're setting it up, but you do have to write something. And then the next ones, you're just going to leave at 1. So payment per year, 1, and compounding per year, 1. As long as your number of compounding periods matches the rate here, that it's the percentage per month, and this is number of months, as long as those times match each other, you're good. Okay, I wrote that over here also. The time units should match. So if interest rate, interest per month, compounding periods should be in per month, number of months. If this is number of years, if it's 5 years, then this should be interest. You know, you're compounding it just once a year, then this should be written as interest per year. Okay, so let's go ahead and put this into the calculator. So let's get the glare off of it. So by the way, you don't have to multiply this out. If you don't know what 12 times 5 is, don't worry, the calculator does. 12 times 5, I put that in. Go to the next one. See, it does the multiplication for you. It says it's 60. Okay, my interest, 2.8 divided by 12. Again, it's going to be totally fine with doing the division for you. Present value, how much I'm starting with, nothing. Payment, I'm going to put in 2,500 each month. Future value, I don't know, so put a 0 or any number, doesn't matter, and then each of these are 1s. Now, to get the future value, to get my answer, I'm going to put my cursor on here. So put cursor. So cursor. Okay, it's going to like highlight this. You're going to put your cursor there, just like I'm showing right here. And then we hit alpha and enter. And it tells me that the future value, my future value, it's going to be worth $160,806. Okay, why does it say negative? I don't know. I haven't quite figured that out yet. Because all this money is going in, so I don't know. I don't know why it puts a negative there, but it does. These numbers, your present value and your future value, are going to have opposite signs for some reason. I'm not sure what. All right, but there it is. There it is on the calculator. So if you can just make sure that you match up the number of compounding periods with that interest rate, make sure the interest rate is written in the same time units as the compounding units are, then you're going to be fine using the graphing calculator, and you won't even need to worry about these formulas. Okay, all 3 of them, doesn't matter. You can do all of these types of problems just by using the same app on your graphing calculator. All right, that's it. Your final exam, in case you're wondering, it's going to be, part of it is going to be in MathSpace, and part of it is going to be show your work, short answer kind of stuff, and you're actually going to have a choice. I'm going to give you a whole bunch of problems, and you only have to pick a few of them to do. All right? But if you start a problem and it has parts A through F, then you're expected to do parts A through F. You can't just do part A of every single problem that I offer you. Okay? You got to pick some problems and do them to the end. All right, more on that later. Hopefully I will have the final exam up and ready for you on Sunday. That's my goal, to have it ready to go Sunday, and then it'll be due the following Thursday, last day of school. All right, take care. If you have any questions, let me know. I will have office hours one more time next week in case you have any last-minute questions. And all late work is due, when did I say? Monday night? Monday at midnight? Okay? So these notes, though, I'll have these notes due on, I don't know, day of the final exam. Since I put them up kind of late, I think that works. All right, take care. Good luck with all your finals and the last week of school. Bye-bye.